Hey everyone, welcome back to the channel. Have you ever looked up at the night sky and wondered what lies beyond our solar system? Far beyond Pluto lies the mysterious Oort Cloud. It's a giant spherical shell enveloping our solar system. What are these icy wanderers made of? And could they pose a threat to Earth? Get ready, we're diving deep into the Oort Cloud. Let's start with the sheer scale of the Oort Cloud, because, trust me, it's mind-boggling. Astronomers estimate that it contains trillions of icy objects. That's right, trillions with a T. To put that in perspective, imagine every grain of sand on every beach on Earth. These aren't your typical planets, though. We're talking about icy remnants left over from the formation of the solar system, cosmic leftovers, if you will. Think about it. Studying these objects is like peeking into a cosmic time machine, revealing the ingredients and processes that led to our solar system's formation. What do we mean by icy objects? The Oort Cloud is like a cosmic snowball factory. Some are tiny grains, just a fraction of a millimeter. Others are kilometers wide, dwarfing skyscrapers. This size diversity suggests a complex formation process over millions of years. Most remain hidden in the Oort Cloud, their secrets waiting to be unlocked. So we've established that the Oort Cloud is vast and teeming with countless icy objects. But here's the real kicker. While each individual object might be relatively small, their combined mass is anything but insignificant. Astronomers estimate that the total mass of the Oort Cloud could be as much as 5 times the mass of Earth. That's right, 5 Earths worth of material scattered across this distant region of our solar system. It tells us that the early solar system was a chaotic and dynamic place, with material being flung outward to incredible distances. But what exactly are these icy wanderers made of? Imagine a cosmic cocktail with a base of water ice because, of course, it's space. Ice that's been frozen for billions of years, preserving molecules from the earliest days of the solar system. Add a dash of ammonia, a sprinkle of methane, and a few other volatile compounds just for good measure. Studying comets reveals the makeup of the Oort Cloud, the building blocks of our solar system. Now, let's rewind the cosmic clock billions of years to the early solar system. Picture a swirling disk of gas and dust, a chaotic nebula where stars are born. At the center of this maelstrom, our sun was just igniting, its nuclear furnace bursting into life. As the young sun gathered material and contracted, a swirling disk of leftover gas and dust formed around it. This was the protoplanetary disk, the birthplace of planets. Close to the sun, where temperatures were scorching, rocky planets like Earth and Mars formed. But how did these icy objects end up so far away from the sun, forming the distant halo we call the Oort Cloud? Well, imagine a cosmic game of billiards, with the gas giants Jupiter, Saturn, Uranus, and Neptune acting as the cue balls. As these massive planets migrated through the early solar system, their immense gravity wreaked havoc on the surrounding icy planetesimals. Some of these icy objects were flung inward, becoming comets that bombarded the inner solar system. Others were hurled outward, cast into the depths of space. Now here's where things get really interesting. While most Oort Cloud objects are thought to have originated within our solar system, some astronomers believe that the cloud may harbor objects that were captured from other star systems. These objects, if they exist, would have formed around other stars, their journeys taking them across vast interstellar distances before being ensnared by the sun's gravity. Imagine the Oort Cloud as a giant cosmic mobile, constantly shifting and evolving under the influence of unseen forces. One of the most significant of these forces is the galactic tide, the gravitational pull of the Milky Way itself. As our solar system orbits the galactic center, it's constantly tugged and pulled by the Milky Way's gravity. These tidal forces can nudge Oort Cloud objects, altering their orbits over millions of years. Occasionally, stars pass relatively close to our solar system, their gravity disrupting the delicate balance of the Oort Cloud. Here's a humbling thought. Despite its vast size and potential significance, no one has ever directly observed the Oort Cloud. It's like a cosmic phantom, its presence inferred but never directly confirmed. Why is it so difficult to see? Well, the Oort Cloud is incredibly far away, and the objects within it are incredibly faint. Even the largest Oort Cloud objects are incredibly dim, reflecting only a tiny fraction of the sunlight that reaches them. Now, this is where things get really speculative, but that's half the fun of astronomy, right? Some astronomers believe that the Oort cloud might not just be home to icy debris, but could also harbor larger objects, hidden worlds that have yet to be discovered. We're talking about potential dwarf planets, even rogue planets, objects that were ejected from their original star systems and now wander the galaxy alone. Think about it. The Oort cloud is constantly bombarded by gravitational forces from passing stars, galactic tides, and even the combined pull of all the matter in the Milky Way. You'd think that these forces would have long ago ripped the Oort cloud apart, scattering its icy inhabitants into interstellar space. But somehow, the Oort cloud persists, its delicate balance maintained over billions of years. Imagine venturing farther and farther from the Sun, past the orbits of the planets, through the Kuiper belt, and into the depths of the Oort cloud. At some point, you'd reach a region where the Sun's gravitational influence begins to wane, where the pull of other stars and the Milky Way becomes dominant. This region, the outer boundary of the Oort cloud, marks the edge of the Sun's gravitational domain, the true boundary of our solar system. Now let's talk about comets, those icy messengers from the depths of space. Specifically, long-period comets, those that take hundreds, thousands, or even millions of years to complete one orbit around the Sun. These icy wanderers are thought to originate in the Oort cloud, their journeys inward triggered by gravitational nudges from passing stars or galactic tides. When a comet is dislodged from the Oort cloud, it begins a long and perilous journey inward toward the Sun. This journey can take millions of years, a testament to the vast distances involved. As the comet approaches the Sun, its icy surface begins to vaporize, creating a glowing coma and often a spectacular tail that can stretch for millions of kilometers. Even the most famous comet of all, Halley's Comet, which graces our skies every 76 years, is thought to have originated in the Oort cloud. Billions of years ago, Halley's Comet was just another icy object in the Oort cloud, minding its own business until a gravitational nudge sent it hurtling inward. While some comets are flung inward on one-way trips to the inner solar system, others have more elliptical orbits, taking them far beyond the Oort cloud before returning to the Sun's vicinity. These comets are like cosmic boomerangs, their orbits shaped by the complex interplay of gravitational forces in the outer solar system. It's a question that has likely crossed your mind. Could an object from the Oort cloud be nudged into a collision course with Earth? The answer, as with many things in astronomy, is a resounding maybe. While the vast majority of Oort cloud objects pose no threat to Earth, there's always a chance that a passing star or galactic tide could perturb the orbit of a large object, sending it hurtling inward toward the inner solar system. Remember New Horizons, the spacecraft that gave us our first close-up views of Pluto? Well, New Horizons is still going strong, speeding outward toward the fringes of our solar system. While it's unlikely to reach the Oort cloud proper, New Horizons might be able to observe the faint glow of Oort cloud objects as it looks back toward the Sun. By studying the Oort cloud, we're not just learning about a distant and mysterious region of our solar system. We're also uncovering clues about the formation and evolution of our planetary system and the processes that shaped it. By studying its composition, structure, and dynamics, we can gain a better understanding of how our solar system formed and evolved over billions of years. The Oort cloud, with its vast size and enigmatic nature, represents one of the ultimate frontiers of space exploration. By studying this distant region, we're not just learning about our own solar system, but also about the boundaries between our solar system and the vast expanse of interstellar space. So there you have it, 20 mind-blowing facts about the Oort cloud, a region so vast and mysterious that it continues to captivate astronomers and ignite our imaginations. From its trillions of icy inhabitants to its potential role as a harbor for interstellar objects, the Oort cloud is a treasure trove of cosmic wonders waiting to be explored. If you enjoyed this cosmic journey, Be sure to hit that subscribe button and ring the notification bell so you don't miss out on future explorations of the universe's greatest mysteries.